When making hot connections, following a specific order is crucial for electrical safety. The recommended sequence is ground, then neutral, and finally hot. This approach minimizes the risk of electrical accidents and protects both personnel and equipment. Firstly, consider the ground wire. The ground wire serves as a primary safety feature in an electrical system, providing a low resistance path for stray voltage or current to return to earth. Connecting the ground wire first ensures that any fault current is safely discharged before any other connections are made. This grounding action significantly reduces the risk of electrical shock and equipment damage. Think of it as establishing a safety net before working with live conductors. Secondly, let's examine the neutral wire. The neutral wire is typically connected to the center tap of a transformer or generator, serving as the return path for current in a single-phase system. Connecting the neutral wire second helps balance the electrical system. This balance is crucial for preventing overvoltages and ensuring stable operation. A balanced neutral also minimizes the risk of voltage fluctuations. These fluctuations can damage sensitive electronic equipment. Thirdly, the hot wires carry the electrical current to the load. Connecting the hot wires last minimizes the risk of accidental contact with live wires. This step is especially important when working with high-voltage systems. Accidental contact with a hot wire can result in severe electrical shock, burns, or even death. By delaying the connection of the hot wires until the ground and neutral connections are secure, the risk of such accidents is greatly reduced. One might wonder why not connect the ground wire last to avoid potential contact with live wires. It's important to remember that the ground wire is the primary safety feature, as mentioned. Connecting the ground wire first ensures that it is already in place before any other connections are made. If a fault occurs during the connection process, the ground wire provides an immediate path for the fault current to flow, tripping the circuit breaker and preventing a dangerous situation. Although contact between neutral wires is generally less dangerous than contact between hot wires, it can still pose a risk. Neutrals can carry significant current, and if they are interconnected incorrectly or at different potentials, a dangerous shock or arc flash can occur. Therefore, it is important to treat all wires with caution and to follow proper safety procedures when making any electrical connection. Understanding the function of each wire and the importance of connecting them in the correct order is essential for electrical safety. Remember the order: ground first, neutral second, and hot last. This sequence minimizes the risk of electrical accidents and ensures the safety of both personnel and equipment. When working with electricity, always prioritize safety. De-energize the circuit whenever possible and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electricity, consult a qualified electrician. Improperly made electrical connections can lead to serious consequences, including electrical shock, fire, and equipment damage. Always double-check your work and follow all applicable electrical codes and regulations. Electrical codes like the National Electrical Code, or NEC, provide detailed guidelines for safe electrical installations. Adhering to these codes is essential for ensuring the safety of electrical systems and preventing accidents. Familiarize yourself with the NEC requirements for grounding, bonding, and overcurrent protection. These requirements are designed to protect people and property from electrical hazards. In addition to following the ground, neutral, hot sequence, it is also important to use proper tools and techniques when making electrical connections. Use insulated tools to prevent accidental contact with live wires. Ensure that all connections are tight and secure to prevent loose connections which can cause overheating and fire. When working with wire connectors, use the correct size connector for the wire gauge. Over or under tightening connectors can damage the wires and create a hazardous situation. Always inspect wires and connectors for damage before use. Damaged wires or connectors can compromise the integrity of the electrical system and increase the risk of electrical shock or fire. When making connections in a junction box, ensure that all wires are properly secured and that the junction box is properly closed. This prevents accidental contact with live wires and protects the connections from damage. Also ensure that the junction box is adequately sized for the number of conductors it contains. Overcrowded junction boxes can lead to overheating and fire. When working with electrical panels, be aware of the potential hazards. Electrical panels contain live wires and components, and contact with these can be fatal. Always de-energize the panel before working on it and use appropriate personal protective equipment. If you are not qualified to work on electrical panels, consult a qualified electrician. Electrical panels should be inspected regularly to ensure that all components are in good working order. Look for signs of corrosion, overheating, or damage. Replace any damaged components immediately. It's also important to ensure that all circuit breakers are properly labeled. This makes it easier to identify and de-energize circuits in the event of an emergency. Keep a record of all electrical work that is performed, including the date the work performed and the name of the person who performed the work. This documentation can be helpful for troubleshooting problems and for ensuring that the electrical system is properly maintained. When making hot connections, it is essential to have a clear understanding of the electrical system and the potential hazards. If you are not comfortable working with electricity, consult a qualified electrician. Never take risks when it comes to electrical safety. Your life and the lives of others may depend on it. Let's delve into more detail about each step in the ground, neutral, hot connection sequence. Starting with the ground connection, the grounding system is designed to provide a low impedance path for fault current to flow back to the source. This low impedance path allows the fault current to quickly trip the circuit breaker or fuse, interrupting the flow of electricity and preventing a dangerous voltage from appearing on metal parts of equipment. The ground wire is typically connected to a grounding electrode, such as a ground rod or a metal water pipe which is buried in the earth. This grounding electrode provides a direct connection to the earth, ensuring that any fault current is safely dissipated. The size of the ground wire is determined by the size of the circuit conductors. The NEC provides tables that specify the minimum size of the ground wire for different circuit sizes. It is important to use the correct size ground wire to ensure that it can safely carry the fault current. When connecting the ground wire, make sure that the connection is tight and secure. A loose ground connection can create a high resistance path which can prevent the ground wire from effectively carrying fault current. Use appropriate grounding connectors to ensure a reliable connection. Moving on to the neutral connection, the neutral wire carries the unbalanced current in a 3-wire single-phase system. In a balanced system, the current in each of the hot wires is equal and the neutral wire carries no current. However, in most real-world situations, the current in the hot wires is not perfectly balanced, and the neutral wire carries the difference between the currents. The neutral wire is typically grounded at the service entrance, which is the point where the electrical service enters the building. This grounding helps to stabilize the voltage and prevent overvoltages. The size of the neutral wire is determined by the size of the circuit conductors, similar to the ground wire. However, in some cases, the neutral wire can be smaller than the hot wires. This is allowed when the neutral wire only carries a small amount of current. When connecting the neutral wire, it is important to maintain proper polarity. The neutral wire should always be connected to the neutral terminal on the electrical panel and on the equipment being powered. Reversing the polarity can create a dangerous situation. Finally, let's discuss the hot connection. The hot wires carry the electricity from the source to the load. In a 120-volt circuit, there is one hot wire and one neutral wire. In a 240-volt circuit, there are two hot wires and one neutral wire. The voltage between the hot wires is 240 volts. The size of the hot wires is determined by the amount of current that the circuit will carry. The NEC provides tables that specify the minimum size of the hot wires for different circuit ampacities. When connecting the hot wires, it is important to use appropriate wire connectors. The connector should be sized to fit the wires and should be designed for the type of wire being used. Make sure that the connections are tight and secure to prevent loose connections, which can cause overheating and fire. When working with multiple circuits in an electrical panel, it is important to keep the wiring neat and organized. This makes it easier to troubleshoot problems and to add or remove circuits in the future. Use wire ties or cable clamps to bundle the wires together and to keep them out of the way. Label each circuit breaker with the corresponding circuit it controls. This makes it easier to identify and de-energize circuits in the event of an emergency. Always follow the NEC and any other applicable electrical codes and regulations when making electrical connections. These codes and regulations are designed to protect people and property from electrical hazards. If you are not comfortable working with electricity, consult a qualified electrician. Never take risks when it comes to electrical safety. In addition to the ground, neutral, hot sequence, there are other important safety precautions to take when making hot connections. Always de-energize the circuit whenever possible. This is the safest way to prevent electrical shock. Use a voltage tester to verify that the circuit is de-energized before working on it. Wear appropriate personal protective equipment, such as insulated gloves and safety glasses. Insulated gloves protect you from electrical shock, and safety glasses protect your eyes from flying debris. Work in a well-lit area. This makes it easier to see what you are doing and reduces the risk of accidents. Keep your work area clean and free of clutter. This prevents tripping hazards and makes it easier to work safely. Avoid working in wet or damp conditions. Water is a conductor of electricity, and working in wet conditions increases the risk of electrical shock. If you must work in wet conditions, use appropriate waterproofing equipment. Never touch electrical wires or components with wet hands. This increases the risk of electrical shock. Be aware of your surroundings. Watch out for other people and objects that could pose a hazard. If you are working in a confined space, make sure that there is adequate ventilation. This prevents the buildup of dangerous gases. If you are working at heights, use appropriate fall protection equipment. This prevents falls, which can cause serious injury or death. Always have a first aid kit on hand. This allows you to treat minor injuries quickly and easily. Know the location of the nearest emergency medical facility. This allows you to get help quickly in the event of a serious injury. Remember, electricity is a powerful force that can be dangerous if not handled properly. By following the ground, neutral, hot sequence and taking other appropriate safety precautions, you can minimize the risk of electrical accidents and ensure the safety of yourself and others.